pH adjustment is the key to the success of wine screening with NMR. A new dedicated instrument now makes light work of adjusting the pH of low quantities in small vials. Meet the BT pH unit. Preparation takes just a few steps. First, choose your samples. For GLP sample tracking, barcodes can be added. With a pipette, place a defined aliquot into your vessel. Unique in titration, this unit only needs a minimum of 300 microliters of sample. The vials should be closed to avoid evaporation or precipitation. Several samples can be prepared and stored on an intermediate storage plate. Before titration, a simple calibration is completed. Remove the neutral storing solution and clean the probe tip to avoid contamination. BT pH probes uniquely integrate the capillaries for buffer, base, and acid within the probe body. Start the titration by selecting the sample and scan the barcode. The name of the sample is automatically recognized and registered. Placing the sample on a shaker ensures sample homogeneity. The probe is lowered into the sample, and at the touch of a button, the pH adjustment and endpoint titration begins. Buffer solution is automatically added, followed by the right amount of reagent. All changes in pH are visible down to 0.1 microliter increments of added reagent. Titration within 0.02 pH units of the target is standard. Intelligent quantity control avoids over-titration. Sample status can be tracked to help information workflow. Audible and visual signals indicate completion. The difference pH adjustment makes is unmistakable. The example shows more than 40 wines from all kinds of origins. With an exact pH setting, a strong chemical shift alignment can be achieved in wine, providing easier quantification and visibly clearer results. pH adjustment is thus a vital factor in achieving highest data quality and optimum reproducibility. The new BT pH unit automates quick, high-precision pH regulation of your samples, a vital step in NMR screening that ensures perfect reproducibility.
The authenticity of our food is a growing concern. Products such as wine, honey, and juice can be high-value items, which are an attractive target for scammers looking to make a profit, passing off inferior or cheaply produced products as high-quality, desirable commodities.
There is a substantial amount of fraud and adulteration. It comes in multiple forms. The most simple of which is adding what's called inverted sugars, such as corn syrup, or rice syrup or beet syrup to stretch the honey to get a higher price for a lower quality product.
We reject over 30% of non-compliant honey every year. We can find false botanical and geographical origin. Sometimes you can have on the label Acacia honey from Hungary mentioned. When we analyze it, it is not compliant. It could be a polyflora, not coming from Hungary, but for example, coming from China.
One of the main things we have down here is blueberry honey. That looks quite different than most of the other things in the database so far. So we can see specific compounds in our spectra that says, oh yeah, this is from blueberries.
Honey in and of itself is supposed to be 18% moisture or less. And many of these honeys, when they're harvested, are about 50% moisture. And so what they're doing is that they're pulling that off of the hive at 50%, and then they're drying it before they bottle it as honey. So you still have sweet, sticky stuff. But is it really honey? No, not really. Testing for those types of adulterations is very difficult until now.
Part of what NMR helps with is that it allows us to stay ahead of the scammers here, because now we get a really good idea of what should be in that honey. Then they can't just come along with some other new technique or something. They have to replicate everything that is in the honey. It no longer becomes profitable for them to slip in something cheap like rice syrup, which costs a tenth of what real honey does.
Bruker's food screener is a fully automated tool based on magnetic resonance, which allows food producers and retailers to ensure the quality and authenticity of their products before they go on the market. Its unique targeted and non-targeted analysis allows the determination of purity, compliance of origin, composition, and freshness. First, samples are set up in the software using a barcode scanner. Labels are printed for the sample tubes to allow them to be tracked throughout the process. A small amount of each honey sample to be analyzed is then weighed out into centrifuge tubes. The samples are diluted with water, mixed and centrifuged to prepare them for NMR analysis. The supernatant liquids are transferred from the centrifuge tubes into pH tubes, ready for automatic pH adjustment using the Bruker BT pH unit. The BT pH unit measures the pH of each sample and adds acid or base as required to adjust them to one preset value without manual interaction. This prevents variations in the NMR chemical shifts due to pH, allowing precise quantification and excellent reproducibility between users, labs, and instruments. When the pH has been adjusted, the sample can be transferred into an NMR tube and inserted into the sample changer of the NMR instrument. Transferring samples into the auto sampler is straightforward, as the next empty holder slot is automatically moved to the insert position. The rest of the analysis procedure runs automatically, with no more manual interaction required. When the analysis is completed, an analysis report is automatically generated for each sample. The report combines quantitative and statistical analysis results, indicating if the honey sample is compliant to the declared geographical origin and floral source, if it is typical to the reference honeys in the database, and if it contains sugar syrups. For more information about the food screener, visit www.bruker.com.
Introducing the MALDI Biotyper from Bruker Daltonics for microbiology of the food chain. The MALDI Biotyper confirms and identifies microorganisms using MALDI-TOF mass spectrometry to determine the unique proteomic fingerprint of an organism. The characteristic spectrum of this proteomic fingerprint is used to reliably and accurately identify a particular microorganism by matching thousands of reference spectra from microorganism strains. To start the process, add your target plate to a MALDI Biotyper project list for easy sample recording and tracking. Next, you can select your isolated colony from selective or non-selective agar plates to be added to your target plate. Transfer biological material as a thin film directly onto a spot on a MALDI target plate. Overlay the material with 1 microliter of matrix solution and dry at room temperature. Put the MALDI target plate into the MALDI Biotyper system and start the acquisition of the protein profile spectrum. The sample matrix complex undergoes UV laser irradiation. The matrix exhibits a maximum of energy absorbance at the wavelength of the laser, avoiding the destruction of the sample by the laser, which triggers desorption of the main compounds. Additionally, the sample is ionized by the slightly acidic matrix. Spectrum acquisition is performed automatically for all samples, plus a quality control spot. The acquired spectra are then matched to the reference library to give confirmation and identification. You can then review and validate your results in accordance with the ISO 17025 standard. The MALDI biotyper is validated by Microval according to the ISO 16140 Part 6 standard and is approved official method of analysis by AOAC International. The confirmation and identification results are provided directly with no need for additional data interpretation. Please contact Bruker for more information on the MALDI biotyper.